As for me, it's very visible.
Yes, very nice.
Okay. So today we'll discuss a little bit about Indian astronomy and mathematics. So you can see this background thing, all these chakras, symbols, the celestial thing, the universe, it all combines. Wait, I have to zoom out. Then I'll be able to explain. So this, I think this is visible. It's 100% zoomed, I guess. The font is visible to everyone. Everyone can read it.
It's visible.
Okay, perfect. Then we'll start.
All right.
See, as we know, India is one of the oldest civilization in the world, and it has a very strong tradition of science and technology. In ancient India, as I have already discussed, that India is land of sages and seers, priests. They were like scientists of that time, as well as like scholars were there. From I can completely and confidently say that from astronomy to metallurgy and mathematics to science, Indians have contributed globally. The origin of this Indian scientific endeavors can be traced from the Vedic period, Vedas, and it is like over 3,000 years ago. So, ancient Indians were the first to study the planetary motions. They even designed the calendars. They studied the time. They studied interdisciplinary nature of many of the different aspects. There is a book. Wait, I'll type the book's name. So before starting, yeah, this is the book. See, why in the first slide, as I have discussed, the earliest evidence of ancient Indian astrological knowledge may be found in Vedang books, Jyotish. In Hindi, astrology is said to be Jyotish, Jyotish Shastra. The major purpose of which to determine the dates of ceremonies and everything. I'll explain this later. Then this figure, sage is sitting, he's writing some formulas, and all these Hindi, Sanskrit text means something. They used to call it sutra. We in present day we call it formulas. Now, okay, everyone got the book's name.
Yes,
So
I'm
this
trying to find a
this
PDF.
yeah, this author, okay, you got the PDF also. This book, Indian Astronomy, it has record for more than 3,000 observations and discoveries by Indian scientists and astronomers and mathematicians over thousands of years. He kind of documented these things, so you can get these things. In ancient India, the science of astronomy was very well advanced. We can't imagine till date that how they achieved such goals, how they have that aircrafts. And when we read all these are mythological and religious texts, we can we can just imagine only. We don't have technology now, however we study, however we research, but that was far beyond our expectation. So in an ancient time, astronomy was called Khagol Shastra. Khagol was like Khagol. There is this word. It's also mentioned in the first slide. It was the famous astronomical observatory and Nalanda. Nalanda was the biggest university of our ancient time. It was in the Gupta's area. Then it was completely demolished by Khilji invasion. So, and now even if you have read the news about India or not, that university again is reopened by our PM Modi. But that was the huge. two university, Nalanda University and Takshila University. They were the two ancient biggest universities. So this Khagol was very famous observatory at Nalanda, where our first and very famous our ancient astronomer and mathematician Aryabhat, who gave the zero, studied there. So, in fact, science of astronomy was highly advanced, and the aim behind that development of this science of astronomy was to have accurate calendars and like a better understanding of climate and rainfall patterns for like sowing of crops, agricultural purpose, then fixing dates for some festivals or some ceremonies at home and in the society. Then for navigation, when the travelers used to navigate, they used to understand that tides were good or not to travel. Then they have calculation of time, and they casted horoscopes also for use of astrology. Like we see that astrology, when we go to some astrologer, we are always keen to ask what is going to happen for our future or something, how our stars are affecting our present, how it have affected our past, and we are very curious to know about the future. So all these things were the main purpose of astrology. Then knowing of astronomy, particularly knowledge of the tides and stars, as I told, this was used, and it was great importance in trade also. Then in this slide you can see, till now I'm understandable to everyone. Am I going fast, or is it okay?
For me, it's okay.
Okay, thank you. See, in this slide, I have there is a Hindu calendar. Hindu calendar is mainly like depicted from the reference of gods. So we have three main gods: Brahma, Vishnu, Mahesh. Brahma is a creator. Vishnu is like Palanhar. He is like what we say in our family, like our father we have, who cares for us, who provides us everything. Lord Vishnu does that. He's our Palanhar, who takes care. And God Shiv is, so he's a protector. So Brahma, who is a creator, he lives 100 years. So his 100 years is not like us. His 1 year, like his one kalp coincides with 1 day of like Brahma's 1 day. 1 day is equal to one kalp, and one kalp has like I can't even read how many zeros are there. That one earthly year, his 1 day is equal to 4320000 earthly years. So you can imagine how long his life is. So that's why, just according to his life cycle, like it was a reference, earth earth the time was divided into yugs. So earlier it was Satyug. First was Satyug. It it was for 4800 years. Then came Treta Yug, when Lord Ram came. Then it was for 3600 years. Then came Dwapar Yug, when Lord Krishna was there. It was for 2400 years. And then Kali Yug, in which we are living. This is Kali Yug. Kali Yug is going on 1200 years. So a calendar for a total of 12,000 years. It's like maths. Complete that cycle only, how it is calculated, it has shown in the calendar cycle. So one can imagine how long a yug can be. Like I have to take like 10 to 20 births, not 10 to 20, like 100 births to complete one yug. Now, before we go to this slide, I have skipped one slide, but it's all in PDF. I always say that I'll give the PDF because I have to compile everything to be understandable. But I guess after 2 or 3 more lectures, I'll compile 5 lectures in a PDF. But these slides I provide after the class only so that you have the pointers. Okay. Now, what was the concept of astronomy? Why it was needed at that time? See, this astronomy concept gave us many things. Like, firstly, the shape of Earth. Even thousands of years before the Western astronomers discovered the shape of Earth to be spherical, Indian astronomers had accurately predicted Earth's shape as spherical. There was a famous astronomer. First one is Varahmihira. It's mentioned here. First, he described Earth as spherical and being suspended in space. He also gave this 4 into 4 magical square. So, during his period, he was in Gupta's period. So, the development of astrological and astronomical sciences reached its pinnacle. In his book, there's a book, Polisa Siddhant. Wait, I'll type. I think I forgot to mention it here. Uh, yeah. Polisa Siddhant is writing from Varamihira. And one more thing, all these astronomers were some or the other, like every astronomer was a mathematician. They were both. So Varamir gives an exact description of not only the shape of the Earth is spherical, but he also provided the topographical study in detail. Now the Western astronomers or Indian scientists, they research and they are just astonished, and they are all like they are in a sense of curiosity how that time he predicted so accurately. The verse in Polisa Siddhant says that Earth is spherical and constituted of 5 elements, Panch Tattva. The whole Earth's surface is spotted by trees, mountains, rivers, ocean, etc. etc. So, in his book, he says that the North Pole, the Meru mountain, according to ancient time, now we say that North Pole and South Pole. If we go in the ancient dialects, they say that Meru mountain, it forms the North Pole where the gods reside, and down below at the South Pole, the demons are down below. As we have seen in I have seen some movie, there's this painting, angels are above and demons are down. I think I have watched that Constantine movie. It's a horror movie. So in that only I saw that picture. Same thing is there. Above on the north side, gods reside, and on the downside, demons reside. So he explained this in his text. Just as the reflection of the object as we see on the water, it's upside down. So we can say that with respect to Dev, like gods are upside down on the South Pole. They are not demon, but we can say that gods are upside down to explain it more precisely and purely. We can say that. Then astronomy also gave the causes of earthquake. There was a Indian astronomer and a mathematician. He lived in Varanasi, Kamlakar. In 17th century, he gave the first detailed account of the causes of earthquake within the earth crust. Like years before the European geologists, when they published about the understanding of Earth's interior and phenomena and earthquake, he before that only in the 17th century only he gave the cause of earthquake in his book. His book is Siddhant Vivek. Wait, I'll come continuously type the book's name. Okay. He stated that earth crust is very hard and rocky. And he also explained the process of earthquake. He writes like how the earthquakes happen. A fissure occurs due to lack of strength, gases emerge forcibly and causing the earth to quake. Today we studied that when the tectonic plates are not in a sync, when they collide, the earthquake happens. So in his dialects, he explained like that. Then the motion of earth. There was a mathematician, astronomer, astrologer. His name was Lala. He in 8th century he discovered that earth traveled from west to east, and if anyone viewed it from north pole star, earth turns left counterclockwise. It's little scientific, so he already explained it. Then the rotation of earth is also from the astronomy of ancient time, Indian ancient time. Then the dimension of earth is completely and well versed in Rig Ved. The first Ved is Rig Ved, and it's written in like 5,000 years ago, and has estimated the dimensions of earth. It mentions that earth, it is by far the oldest document we speak, and it gives a very precise dimension and size of earth. Varamihir, he built assumptions on Rigved time and accurately estimated the circumference of the earth as 3200 yojans. Yojan is, wait, 1 yojan is 4.5 miles. So 3200 yojans, he explained. Furthermore, like each yojan is 12 to 15 kilometers, which translate like 38,000 kilometer to 45,000 kilometer, which is almost accurate to the current estimate. Now, so he also described, he used latitudes and longitudes. Then he described stars as fixed and gave the planets as a constant speed. Then he also explained the diameter not only for the planet Earth but also for like Mercury, Venus, Mars, Saturn, Jupiter, other planets also. And he was the first person who predicted underground water. His claim that plants and termites serve as indicator of underground water and is now receiving attention in scientific world. Like scientists now, they prove that their course is very important. These insects are very important, like earthworms are very important, but he already predicted it. So we can just imagine only how intelligent they were, and with minimum facilities, they predicted, they studies these things. Then there, before going to Brahmagupta 1, we'll just discuss some what are the Indian astronomy legacy, like Vedic foundations. The roots of Indian astronomy can be traced back to the Veda period, as I already told. Then there were Siddhants. Ancient Indian astronomers developed several treaties. Siddhants are treaties that explored the motion of celestial bodies. Then there were instruments to help them out to study and tracking and measure the position of stars. Their influence was beyond the borders also. The knowledge of Indian astronomy at that time spread to the neighboring religions like Greece. Just imagine, Greece was also connected to India, where it played a very crucial role in development of Hellenistic astronomy. It's a Greek. There was a very famous Greek astronomer, Hipparchus, I think, is known to have incorporated Indian astronomical ideas. So this knowledge of Indian astronomy helped him to develop his work. Then there was cultural and spiritual significance also. As I told, we are very much curious to know about past, present, and future through astronomy. So it's our cultural and it's our religious belief also. Not every person goes to some astrologer. So whoever believes, they go. So it has some spiritual significance also. Now, Brahmagupta I. He was the another astronomer and mathematician. He estimated the Earth's circumference as 5,000 yojans. 5,000 into 4.5 miles equals to, I don't know. So that is the Earth's circumference. He also introduced the concept and computation method of zero as number and defined its properties and operations. See, here is a shlok is written, and the meaning also of this shlok is written here. As a wheel rotates on its axis, in the name of mechanics, all the planets rotate around their axis and revolves around the sun. We study like solar system. And there was a famous astronomer, Devacharya. He described the method for calculating the precision of equinoxes. Equinox is like event which is in which a planet's subpolar point passes through its equator, and it's the only time when the north and southern hemisphere experience roughly equal amount of daytime and nighttime. Equal, day and night are equal. That is equinox. So Devachar already told. Then there is this Bhaskaracharya. He was the leading light in 12th century. You can see in the why I'm mentioning these scientists. They have done their research, their work in early centuries. We are in like 21st century, and they were 12th century. You can imagine the gap, the generation gap, the century gap, the knowledge gap is there. Still we hold the roots long before our birth, long before our generational births, and still we are taking these bases and we are still researching. So it has literally helped us. I'll skip this slide. You can you guys, whenever you get time, and you can read it. Then we'll the very famous mathematician and astronomer Aryabhat. Wait, just give me 1 minute. Yeah. So Aryabhat was one of the greatest mathematician of India. He was also an astrologer. He studied at Nalanda University. He was the first of the he's also known as father of Indian cyclic astronomy. In the picture you can see he did he gave the value of pi. According to documented history, the irrationality of pi was proved in Europe only in 1761 by Lambert. But the great Aryabhat worked on approximation of the value of pi and conducted that irrational and its value. He did that like 499 common C at the age of 23. So long before. Okay. So there are two famous books he contributed in the field of mathematics. There's this Aryabhat Siddhant and Aryabhatiya. Wait. These two are his famous work. Aryabhatiya was written somewhat like 499 AD, and when he was 24 years old, it all covers mathematical theorems and theories. They're like topics, tables of sine, trigonometry, algebra, fractions. And this Aryabhatiya is also translated in different languages. Like it's in Latin, French, German, Greek. Arabs also adopted this book. Then Aryabhat Siddhant. It is the book based on astronomical computation. It has some information he did research on solar system. Now, if we see the contribution of Aryabhat in maths, wait, first we'll see the astronomy thing. He determined the position of planets in space, where all the planets are, where what their positions are. Then he found the circumference and diameter of Earth. He found the Earth's axial rotation. He also calculated the radius of planetary orbits. He estimated the period of rotation around the sun, how many rotations does a planet take. Yeah, what is the period, how long one rotation completes for any planet, specific planet. He also found the moon shines because the he we as a kid we got to know that moon doesn't have its own light. It always shine with the reflection of sun. And Aryabhat gave this theory long back. He found the cause of eclipses of sun. We have solar eclipse, lunar eclipse. He gave the reason for these eclipses. He was the first to tell the length of the year at 365 days, 6 hours, 12 minutes, 30 seconds. So you can imagine how much he has contributed to not just Indian astronomy but the world's astronomy. Now his contribution in maths is also far, far, far. He introduced the alphabetical counting system. He was the first to do calculations on the square and cubic root. He gave the solution to the equation by this formula. He was the first to provide the approximate value of pi. He was the one who said that pi is an irrational number. He formulated tables of sine. He gave trigonometry also. So these are some of his various contribution in maths. There are some also interesting facts about Aryabhat. The Hindu calendar is based on Aryabhat's calculation. There's this Aryabhat Research Institute of Observational Sciences. It was specifically set up for research in astrophysics and astronomy, and it has been named after him. He studied at Nalanda University. It's in Bihar, and he served as the head also at this university. And there are a few awards also named after him. That Aryabhat Award is awarded to the individuals with notable lifetime contribution in maths and astronomy. Even our lunar impact crater was named after Aryabhat. Our first satellite was named under Aryabhat. There's also a Aryabhat College in Delhi, the capital city. There are like few famous inventions on math. Zero, given by our astronomer Aryabhat. Then algebra. This is also from ancient Indian mathematicians. There was conventional mathematics. It was termed as Ganitam. Wait, I'll type it. This was conventional maths that time, and it was known before the development of algebra. So algebra in Hindi is called Bij Gadit, and Bij Ganitam is a Sanskrit text. Bij means another or second, and Ganitam means maths. This Ganitam terms, it means mathematics. So in India, around 5th century, a system of mathematics that made astronomical calculations very easy was developed that time, and its implication was limited to astronomy as its pioneers were astronomers only. Algebra is a shorthand method of calculation, everyone knows that, and it also scores conventional arithmetic. Then trigonometry. Though trigonometry goes back to the Greek period, the subject's character started to resemble modern form only after the time of Aryabhat. So Aryabhat already studied that. It went to Europe through the Arabs and went into several modification to reach its present form. So it's like a cycle from one country to another, one era to another era. But in ancient times, trigonometry was considered a part of astronomy only. Three functions were introduced: Jay, Kojay, and Ukramajay. These were the three functions. The first, okay, the first one was sine, r sina, which we studied like sine theta, cos theta, tan theta. If you guys know a little bit about trigonometry, so it was in ancient, it was like sina for the center, cosa, the third one. So there were a different meaning of these mathematical terms, but it was mainly used for astronomy at that time, in the time of Aryabhat. Then decimal system and quadratic formula was also made by scholars like Aryabhat, Brahmagupta, Mahavir, Bhaskar. They did that decimal system. Then we have you heard about Fibonacci numbers? Anyone?
Sure, certainly.
Okay. So Fibonacci sequence is a series of number where a number is found by adding up the two numbers before it, starting with like for example 0 and 1. The sequence goes as 0 1 1 2 3 5, like that. So Virhanka and Gopala and Hemchandra, they were the first to describe it as an outgrowth of early writings. Say this is also being mentioned in Indian mathematics, Indian ancient mathematics. Now, all these length, weight, geometry. See, geometry, Indian mathematicians had their like vast contribution even in the area of geometry also. There was an era of mathematical application called Rekha Ganit. Geometry in Hindi is known as Rekha. Rekha means line, and geometry is completely lines. Wait, I'll type it here. That time it was said as Rekha Ganit. Geometry. Yeah. Then the binary code, binary numbers from the basis for the operation of computers, which is being used now. It was also discovered in our ancient text. The source of this discovery is a text of music by Pingal named Chandra Shastra, meaning science of meters. So this binary code falls under this category of Sutra. He discussed it, and it was the same pattern as of the binary codes now being used in the computer operations. So you can just imagine it was like in early 20th century, 12th century and 13th century, this discovery was made. I guess I'm on the last slide. I have discussed this slide. So this is all about like collaborative discussion about Indian astronomy and mathematics. So our ancient scientists, mathematicians, and astronomers have already given the base of what we study today. Their predictions, their way of studying the, because they always connected in the previous lecture, as I told, all these sages years, they connected with the environment, they connected with the universe, they studied each and every phenomena going in their environment. They had that curiosity of questioning it, how the plant grows, how the star moves, how the star shines, how the wind blows, how the water flows. So in their every question they had some logic, and they have a very reasonable explanation for that. They studied their core hard, and they just documented, they written their findings. Now we are just moving ahead with those ancient findings. We are even the, like, our Chandrayaan 3 soft landing on the south pole of the moon, our recent lunar mission, that was also had some basis of our ancient knowledge. Even the British East India Company was impressed with our Indian rockets, and they adapted them to use against Napoleon Bonaparte in the Battle of Waterloo. So we can completely see that in present times also, whatever discoveries we are making, whatever inventions we are doing, each and everything has basis of our ancient notable knowledge. And not being an Indian, I'm literally and like widely, I'm proud that I have such a rich and cultural past, and I have such a grand endeavor of this knowledge in which I'm at present today. When I'm just delivering this lecture, I also go and research, because I can't have a vast knowledge of everything. So when I go into the girth of all these things, I'm always amazed to learn new things. I keep imagining what technology they used, how they made these discoveries, how they connected with the environment. They have such a long way of thinking to predict future phenomena. Now like group of scientists do these works. At that time every individual was like an individual team of army. They had such a huge way of thinking. Now if we have to achieve something, there is a complete team, but they were on their own without any facility, but they worked for humankind. All these findings, all these research, they that wasn't for personal use. They always did whatever their doings were, they it was for the society, it was for the future generation. So this is also like a praise thing for us, and new generation also. Whatever we read, whatever we do, whatever we find, whatever we research, it should have some long way of impact in the society. It shouldn't be for some degree or anything. Why we are studying? Until and unless we share our knowledge, it's of no use. We study to practice. So practice can be done in various form. If I have done my research on anything, like my PhD research is on energy diplomacy. So why I have taken this topic? Because in this era of global warming, our resources are getting reduced, and before digging up for the energy resources, we have to parallelly think about the environment we are living. We can't just go on depleting, deploying, and destructing our environment just to gain something from it. So we have to make a sustainable balance also. That's why we are researching. So what I'm going to contribute to the my coming generation, what I'm here to explain to them, how to be, because all the times doesn't remain same. The environment, the condition is favorable for me today, I don't know it's going to be favorable for my future generation. So I have to make, like, I have to document something so that I can prepare them, whether I'm tomorrow I'm here or not. at least these texts, these documents will help our future generation to study it and do go beyond their imagination and do something, flourish something, and give it to the society. So I guess this was all. It was a very short and precise lecture because it's already late. I hope I was able to explain it in a very short span. This slide has some technical terms, but when you will read it slowly, you will get to understand it.
Well, Sinkat, thank you very much for this. It's been really instructive, and I do have a few comments before we open for questions and comments from the audience. Maybe if you could just show that slide again, would it be possible?
Okay. Just a second.
And I would like to say this not only to you, but to everybody here, and the next one, the one about Bhaskaracharya.
Wait. This one.
Yes, this one. Well, first, I think many people often forget that India was a great nation long before any Western nation ever existed. And even we can think of the oldest Western nation, maybe the Roman Empire, and India was already there for a long time. So we often forget that things were going on in a very evolved way in India long before they were in the West. And it's impressive how we forget that a lot of this knowledge comes from India. As a teacher, I love to study etymology and the origin of words. And as you delivered this lecture today, I noticed how much of what you taught here is taught in Brazilian schools as well. And often it's not said, it comes from India. They just teach, for example, the mathematical teachings of Bhaskaracharya. They're taught in Brazilian schools. Everyone here in this room has studied the mathematical principles of Bhaskaracharya. I'm sure everybody did. We could have a show of hands here. Who among you have studied the Bhaskara equations? Everybody here, I'm very sure. People might hate it because we don't like mathematics a lot, but it's everywhere. I mean, we do study it here. And when we started this course, I might have told you that Indian history is taught in Brazilian schools. Nearly everybody knows about India, about the independence process, about Gandhi. But after today, after what you showed us today, I came to realize that the depth of Indian knowledge that we learn here, even without knowing it's from India, it's much deeper. So it's really impressive, and I'm really grateful that you have showed that to us today. And well, it's really impressive, and I think it's very valid to remember that India was a great nation long before any other Western nation ever was there.
Yeah, there's this saying we say it like Bharat Khande Aryavarte. Aryavart, it was a land of Aryans. Like all the there's this Aryan race in the Greeks. It earlier it was all before this division of this land. There was Gondwana plateau and there was this different plateaus were there before the division. It was like a whole space was there. So all these countries they lived together. So it was completely a term for these Aryans. India was Khand means a piece of land, like Khand, peace. So Bharat Khande, piece of Bharat, and Aryavarte, jahan pe where Aryans lived. So we can see that, like in ancient time, everyone was together. When the lands divided, when the countries divided, they migrated some or the other way. We are all connected by blood, by race. But now we are citizens of different countries, so we have now developed our different culture, different religion. But in a whole, we are a system.
Yes, indeed. Indeed, that's a very good perspective. It's really beautiful. Well, I think we have some comments from the audience. Any questions? I know that the time is late, even for Snitha, because of this.
Yeah, it's
situation we had
7:30
today.
evening here.
Yes. So if we do have a quick questions from the audience.
I guess today's lecture is quite scientific. I do have many questions for my own lecture.
And sorry, my dogs.
Oh, you have cats and dogs both.
I do. I have 2 dogs and 3 cats, and yeah, the dogs sometimes they like to bark at nothing. But it's really
My dogs.
amazing. Everything you
After,
choose.
after dark.
Sorry.
No, you said na your dogs like to bark, and my 2 dogs, they bark only after dark. Before that, they don't bark. No matter whoever comes in or goes out, it hardly matters. But after dark, like during the dark time, like in the evening,
They
after
don't
the
want you to
sunset,
sleep.
they continuously bark. With my own movement, they start barking until and unless I go near to them.
Yes.
They are always on the guard duty.
Well, the book you mentioned, Indian Astronomy, a source book. I have found a PDF of it. I sent it in the group, so it's
Okay.
already there. And so we don't take much more of your time because I know it's late. I will send the link to the attendance form to our group, WhatsApp group, so people who want to fill the attendance form can get the link from there, right? So I think we don't have any questions today.